Okay, so again, b is greater than 0. I'm saying the graph of y equals a b to the x has to be asymptotic to the positive x-axis. If b is less than 0, the graph is asymptotic to the negative y-axis. I'm going to show why that's true. Because, well, when you see an exponential function, you want to know which way it goes. Well, first of all, let's just see what it looks like, and then we'll see why it happens. And you know what? I said that completely wrong. Said it without thinking. And when I was going to get into showing you why, it wouldn't have worked, and I would realize that I had these exactly reversed. Wrote it down without visualizing or thinking, and you always want to test your statements. So by drawing this graph, I tested it and found out that it was wrong. So this will be asymptotic to the negative x-axis, and this to the positive y-axis. Now the basic exponential function was the y equals 2 to the x function, and it has a graph that looks like this, and it's clearly asymptotic to the negative x-axis, and it's pretty obvious why. Because if you start taking negative powers, the negative 1 power of the 2 to the x function gives you 1/2, negative 2 power gives you 1/4, which is half of that, and every time you move a unit to the left, it gets half as high. Okay? Every time you move a unit to the right, of course, it doubles. Well, that shows you why as you move to the left, the y value approaches 0, never reaches 0, approaches 0, and the graph is then going to be asymptotic to the negative y-axis. Now, if b is less than 0, turns out your graph will have characteristic of the 2 to the x function if you reflect it through the y-axis. Okay, well, let's see why all this is true. Okay, so okay, if b is greater than 0, then, and let's just do this. B is greater than 0, b to the negative 1 is 1 over b, b to the negative 2 is 1 over b squared, b to the negative 3 would be 1 over b cubed, and so forth, and b to the negative n is 1 over b to the n. Since b is positive, multiplying by b increases the result. So b is less than b squared, which is less than b cubed. Which is less than, and so forth, up to any power of b. These numbers keep getting bigger. Not only that, but since the numbers are getting bigger, when you multiply by b, the increase in the number is going to get bigger. Now, I'm not going to go into a lot of detail on that point, although I'd love to, because I just find that at the pre-calculus level, people have trouble understanding that sort of thing, and it's not worth the effort. Okay, it's not worth the time it takes to get you to think through it, not worth your time, and not worth class time. So I'm just going to say, b to the negative n approaches 0 as a limit now I'll just say b to the negative x actually I'm going to say b to the x approaches 0 as a limit when x approaches negative infinity, which is what makes the graph do this. For example, two to the negative 1 is 1/2, 2 to the negative 2 is 1/4, 2 to the negative 3 is 1/8, 2 to the negative 4 is 1/16. Then a few dots, we go skip down to 2 to the negative 10, which is 1 over 1,024. 2 to the negative 20 would be somewhat less than 1 over 1,000,000. 2 to the negative 30, well, 1 over 1,000,000,000, and so forth, okay? So for these x values, -1, -2, and so forth, 2 to the x approaches 0. And the graph of 2 to the x and 2 to the x has an asymptote at the negative x-axis. Okay? Now, if b is less than 0, one over b is greater than 1. Now, remember that b always has to be positive, okay? So we're not going to consider values of b that are negative, because of course if b was negative, 1 over b would be negative, and that wouldn't be greater than 1. But we don't use negative numbers for exponential functions. Exponential functions can't be represented by negative base. The base b always has to be positive. It can be bigger than 1, it can be less than 1, but it always has to be positive. B is less than 0, 1 over b is bigger than 1, and I said b less than 0, which is exactly what I was saying you couldn't say. If b is less than 1, 1 over b is greater than 1. B has to be greater than 0, so it's between 0 and 1. 1 over b is greater than 1. And I'm talking about 1 over b because I want to establish that what happens for negative b, but I don't really need to do that, so I'm going to just kind of say what I really need to say because I don't have much room to say it here. Okay. Now let's get my statement straight. If b is less, if the positive number b is less than 1, then b squared is less than b, because if you multiply a number less than 1 by another number, you get a number that's less. So if you multiply b by b, you're going to get a number less than b. Well, that's b squared. And b cubed, which is b times b squared, has to be less than b squared. And so forth. So, we have this sequence of b values, each less than the other one. So the values of b to the x decrease. So values of b to the x decrease for larger and larger values of x. If b is 1/2, 1/2 squared is 1/4. 1/2 cubed is 1/8. 1/2 to the 10th is 1 over 1024. These numbers approach 0. Okay, so let's look at these. Just as an example, if b equals 2, we get our y equals 2 to the x function. It's asymptote at the negative x-axis over here. B equals 1/2, we get one half to the x, and in this example we see that those values approach 0. By the time you get out to x equals 10, you have 1/2 to the 10th, which is less than 1/1000th. It's really close to the y-axis. And the asymptote is at the positive x-axis. Okay, well these are things you're going to want to see, and we're going to want to understand when you get into the next assignment, which is not due until next Monday, week from today. And Wednesday we'll talk about a little more of the stuff you need, but you can start taking a look at that assignment because you already, if you understand this, have a lot of the tools.